I work in data sciences and statistics, and I'm working on the part of the project which works on analytics and supporting project analytics and coming up with novel analytical strategies to analyze the data that we have. The platform it's a central repository where we store all of the data that we collect. So we have many studies from across the hematological malignancies which are being loaded onto the data platform. And the real value of the data platform is it really will protect patient privacy, so the patient data is completely anonymized, and the platform is completely encrypted. So data privacy, patient data privacy is protected. And the value of the platform is that we have a kind of interface. The idea is to have an interface so that we can view all of the studies that are on the platform, all the kind of data that's available, and we can generate larger studies. We can generate studies at scale and be performing the kind of analytics that we couldn't be performing in smaller studies with much more information. So now we can start to use much more interesting analytics, kind of predictive analytics, machine learning algorithms that everyone's talking about. So we can start to be predicting patient outcomes and really be identifying how to treat patients better. So one thing is we have various different types of data. So we have the clinical data, which is all about the kind of features which describe the disease. And from that, we're really looking at how we can identify, kind of hone in on what outcomes are really important. So what outcomes are important to patients, what outcomes are really going to help us identify how to help patients survive longer, and also to have better quality of life, and what quality of life really means to patients with these diseases. On top of that, we of course have data on clinical management and treatment pathways, and from that we'll really be able to identify how patients are really being treated in the real world and what treatments are really most effective and how we can be treating these patients better. And on top of that, additionally, we'll be looking at having as much molecular data as we can. So what proteins are expressed on the cells, on the cancer cells, what the genomes of these cancer cells look like, how this impacts treatment, how treatment impacts the molecular makeup of the disease. And from all this, we can really start to hone in on how to personalize medicine and make it the best possible medicine for our particular person.